Assalamualaikum and good morning. I will begin by introducing the concept of situational awareness or SA and why is it critical in modern operational environments. Situational awareness is a fundamental requirement in safety critical operations, especially in environments where conditions change rapidly and continuous monitoring is required. In domains such as military operations, healthcare, and aviation, poor situational awareness can directly lead to human error, system failure, or even fatal consequences. Because of this, there is an increasing need for sensory enhancement technologies that can support operators working in high risk and information dense environments. These operations often demand rapid observation, assessment, and response to environmental changes, which is essential for effective hazard mitigation. In this context, wearable technologies have emerged as a core capability compared to conventional hazard monitoring systems. Wearable equipment offer a significant advantage because it allows information to be delivered directly to the operator without diverting attention from the task. This makes wearable system particularly effective for enhancing situational awareness. One key technology enabling this is augmented reality or AR. AR allows digital information to be overlaid into the real world, enabling operators to perceive real-time contextual information while remaining focused on their physical environment. This real-time contextual support is a major contributor to heightened situational awareness. However, simply presenting more information is not enough. If information is poorly structured or excessive, it can lead to information overload, which is negatively affect decision making. Therefore, effective information representation and fusion are crucial to ensure that only relevant and meaningful information is presented to the operator. This is where artificial intelligence, particularly AI-based computer vision, becomes important. Recent advancements in AI have created opportunities for intelligent data fusion, allowing information from multiple sensors sources to be processed, filtered, and presented in a more effective manner. Despite this potential, the integration of AI with wearable AR and head-mounted system for situational awareness is still not clearly explored in the literature. Many existing approaches lack innovation in how these technologies are combined, even though they play a critical role in safety and security. Therefore, in this work, we review AI-based computer vision techniques that support situational awareness and examine how they integrate with wearable AR and head-mounted system technologies. We also discuss key concepts necessary to understand this technological stack and highlight its significance across operational domains.
To better frame this discussion, it is important to first understand what situational awareness actually means. The foundational model of situational awareness used in modern research is Ensley's model, which defines situational awareness as the perception of elements in the environment, the comprehension of their meaning, and the projection of their future status. This model consists of three hierarchical levels. Level 1, perception, involving detecting relevant elements in the environment such as objects, events, or signals. Level 2, comprehension, referring to understanding what those perceived elements mean and how they relate to one another. And level 3, projection, which involves anticipating future states or outcomes based on that understanding. Each level builds upon the previous one. In other words, projection depends on comprehension, and comprehension depends on an accurate perception. If perception fails, higher levels of situational awareness are compromised. More recent studies have expanded this model to better reflect modern socio-technical systems. For example, Fang and colleagues classify situational awareness research into three perspectives. The first is ergonomics-centered, which focuses on human factors such as workload, attention, and interface design. Second is human-centered, which emphasizes cognitive processes and how operators make decisions. The third is machine-centered, which examines the role of automated and intelligent systems in perceiving and interpreting dynamic environments. This expanded view is particularly relevant today, as situational awareness is no longer purely a human capability, but increasingly a shared responsibility between humans and intelligent systems. Figure 1 illustrates the basic structure of Ensley's situational awareness model, which serves as the conceptual foundation of this work.
Moving forward to AI-based computer vision for situational awareness in wearable augmented reality, AI able to help users to understand their environment in real time without overwhelming them. Through research paper, we found that most of the model used for CV are YOLO V8 and Dino to be applied in devices such as HoloLens, which utilize wearable edge computing node. This is to perform complex tasks like image segmentation and 3D spatial mapping, which with low latency. Not to mention, the AI also used the clustering of unsupervised learning for object classification. The advantage of using the device during this paper experiment is achieving context-aware relevance. For example, as in paper Caracostas 2024, the AR head-mounted able to identify the warning of industrial machine and its condition. The AR will then display its UI or in terms of sensor visual, audio, or auditory visual for warning and active decision-making assistant. However, after the experiment, user explained some limitation occurred whereby hardware constraint making it heat after few minutes use, cognitive overload where the information is too much to be consumed by user while also the incompatibility with the UI causing it stress, accuracy degradation as the testing handled in crowded place.
Building on our current findings, we look to a future where AI and AR don't just display data, but fundamentally enhance human capability. To get there, our research highlights several critical next steps. First, we need to move from the lab to real-world validation through longitudinal studies. The focus must shift to the lightweight models and edge computing to solve current battery drain and heat issues. Furthermore, we must prioritize goal-driven interface that filter out noise to prevent information overload, ensuring users only can see what is critical. When this system mature, the contribution to society is immense. For example, in safety, we can decrease hazard in industrial environment and increase success rate in high-risk medical emergency. In efficiency, early prevention through AI observation reduce incident root cause and speed up complex operation. Finally, in security, tasks like border observation can be automated, allowing for effective crowd control with fewer personnel required on the ground. Ultimately, the goal is a seamless integration of perception and comprehension. By mastering domain-specific semantics in fields like healthcare and the military, we are creating a world where AI-driven prediction adjusts human perception in real time for a safer, more efficient society. Thank you.